For scores of centuries, men have put to sea in ships, lured by the challenge of the unknown. Out here, 30 kilometres off the east coast of Australia, the unknown lies on the ocean floor, 4.5 kilometres below us. On October 20th, 1988, the oceanographic research vessel Franklin left the security of Sydney Harbour on a voyage of discovery. Over the next 11 days, the team of biologists would search around the clock for the strange creatures that inhabit the cold, dark world at the edge of the abyss.
One of the problems with sampling at this depth is you really don't know what you're doing. It's like flying above clouds and dropping something through the clouds and dragging it through the city of Melbourne and hoping to catch people. It really is a bit like that.
Dr. Gary Poor, originally from New Zealand, is chief scientist for this expedition. Veteran of numerous oceanographic voyages, well aware of the hard work ahead, the hazards of mountainous seas and gale force winds, Gary believes this trip will unlock secrets about the kinds of creatures that live on and above the slope leading down from Australia's continental shelf to the abyssal plain. Here, in an office at the Museum of Victoria, I listened as the scientists finalised plans for the voyage. Dr. Laurie Hammond directs the Victorian Institute of Marine Sciences. On projects like this, his institute works closely with biologists from the Museum of Victoria, like polychaete expert Robin Wilson. Dr. Martin Goman, a graduate of the University of Miami, is the museum's resident fish expert. He's trying to make sense of the often bizarre array of fish living in the water column between surface and sea floor. Capping this international array of biologists is Dr. Jean Just from Denmark, who with Gary Poor will be studying tiny crustaceans from the seafloor. Together, the team will be taking on its toughest challenge yet, sending their underwater gear deeper than ever before, all to unravel the origin and evolution of Australia's marine fauna.
Whenever people do what is termed biogeography, that means the distribution and origin and the dispersal and migrating of animals around the globe, they always come up with a big blank in Australian deep waters because nothing is known from those areas.
Plans for the Franklin expedition were laid well in advance. The team of 6 oceanographers had learned a great deal from an earlier voyage on which they'd obtained samples from just over the edge of the continental shelf. What they found was surprising, a whole array of creatures, many previously unknown to science. In fact, the problem was to find any creature they could identify.
There's a greater variety of forms in this material than anywhere else in the world, and we haven't even really got into the deepest part of that yet.
Getting to the deepest part was the point of this voyage, and it's a tricky business. There are basically two ways to sample benthic or seafloor animals. You can drop a sampler vertically and snap up a bite of seabed, or you can drag a sled along the seafloor, scooping as you go. The sled collects samples from a far larger area, but because the device trails behind the ship, it can't operate at the full depth of the cable. The plan for this voyage was to sample along each of 3 transects, selected to give access to creatures from waters of quite different origins. One off Sydney, the second off the eastern edge of Bass Strait, the third off Tasmania's Freycinet Peninsula. All in waters known to be treacherous, wild and unpredictable. Fortunately, Franklin is well able to meet the challenge. At 1,200 tonnes and powered by a 2,000 horsepower Swedish-built V12 diesel, Franklin was commissioned in 1985 as flagship of a new era of oceanography in Australia. Owned and operated by the Commonwealth Scientific and Industrial Research Organisation, CSIRO, Franklin is run as a national facility, readily available for use by Australian oceanographers.
We'll come back up at full speed again.
Unlike most oceanographic ships, which must be fitted out by each successive research team, Franklin comes fully equipped with a dazzling array of onboard computers and electronic gear, as well as the very latest in satellite navigation systems that enable her to be positioned to within metres on the open ocean. Despite the obvious dangers of working with the stern gates open, there's a contagious thrill of excitement each time a sampler is hauled on board. This seafloor ooze contained a dazzling array of microscopic life. I suggested to Jean that he looked a bit like a treasure hunter.
Well, it is precious for us, so it's a bit like panning gold.
Well, we've got some of these deeper water crabs, or false crabs, the ones with the big horns on the front. Swimming crabs, not too uncommon. Good catch of hermit crabs. And of course a lot of these prawns. We don't have many prawns in our collection. Probably because most of them have been eaten, I think, by people who've been out collecting. But, you know, it's a good feed, but it's good for the collection too. Makes a good reference point.
This is just amazing. The sediment's pretty typical of a lot of the coast around here. It's rubble of all sorts of animals, and it's... Ow! There's a few big animals in here, but if you put this under the microscope, it's just a zoo. There's millions of beasties in there. So many of them were just new to us. Completely new to us.
Using information from the satellite guidance system, combined with his expert knowledge of the navigation charts, Captain Neil Cheshire guides Victor Juliet Foxtrot, as Franklin is known to the radio telephone network, along the first transect. I asked the skipper about the reliability of the satellite navigation system.
I think all electronic navigation systems, the main thing is not to rely on one particular system. The GPS could say give you a position 2 miles off a particular island, but the island itself is 2 miles out of position, so you could be aground.
There are other dangers as well. Every now and then a larger than usual wave would wash over the stern. I asked the bosun, Yannick Hansen, how bad it could get.
Oh, it can get quite big. One day there was a buoy that broke its mooring off Western Australia in seas similar to this, and we were backing up into the seas when it took a greenie, and I was a couple of feet off the deck and it was up to my chest. I jumped up onto the winch frame and wrapped my arm around one of the stanchions, just hung on. And we had a clean deck after that. It was pretty good.
Early in the trip, Martin Goman is keen to try out a new piece of gear. Looking a bit like a hang glider that went wrong, the mid-water trawl is trailed from a cable at a preset depth, collecting plankton and fish in a fine net, just like a manta ray. Martin's manta can be fitted with a computer to record water temperature, salinity and depth throughout the trawl. Among other things, this provides a cross-check on the depth of the trawl, a critical step in interpreting the animal treasures captured in the net. It takes a while to lower the sampler. For this run, we have to lay out about 1 kilometre of 12mm steel cable. Winching time is a great time for a break. Spirits are high, the weather's good, months of planning are being turned at last to action, and the midwater trawl, for all the world like a gleaming metallic manta ray, is silently filter feeding 800 metres below us. For safety reasons, Franklin is a dry ship. No celebratory toast of champagne tonight, but the coffee's great. The manta's progress, and indeed the progress of Franklin herself, is monitored constantly and relayed to various locations around the ship. Nerve centre of the system is the operations room, where cruise manager Dave Vaudry keeps nightly vigil on the array of computers.
Come on, you lot. He's coming in.
Landing the trawl is about as difficult as landing a live manta, but considerably more dangerous. This one has wings of steel and the deck never stops pitching. I noticed that Dave Vaudry kept a watchful eye on this procedure. With half a ton of steel flinging around an open deck, there's no room for error. Even in small seas like these, the swell makes every step a balancing act, and the deck is slippery with seawater. Understandably, everyone's a bit edgy until the stern gates are safely shut. Even at this early stage of the trip, the nets are hauling in surprises. Throughout the trip, Martin Goman was confronted continually with problems of classification. One afternoon, he drew my attention to this little fish.
What's this one, Martin?
I really couldn't tell you, David. It's something that's totally new to me. It's a fish that has the same general appearance as some of the viper fishes, but it's got very small mouth and virtually no teeth, so it's totally new to me.
Viper fish are normally fitted out with large, well-armed jaws. They feed on smaller fish like lanternfish, which are intercepted during the lanternfish's nightly migration to the surface to feed on plankton.
Every now and then something like this one pops up, and it's quite an interesting find.
All the major continents on Earth are surrounded by a continental shelf, a fairly flat plain defined by the limit of the 200-metre depth contour. Beyond that limit, the seafloor drops off fast, plunging to about 4,000 metres, then levelling off to meet the abyssal plain at 5,000 metres. To date, Australian marine research has concentrated on inshore waters and on waters overlying the continental shelf, areas of prime importance to inshore fisheries. But the questions now being addressed by marine biologists have to do with how those creatures came to live over the shelf and where they came from in the first place. To make sense of such problems, we have to take a step back in time. Australia has not always been in its present position on the globe, nor has it always had its present shape. 100 million years ago, the continents of South America and Australia remained firmly attached to Antarctica. The climate was warmer then, and the supercontinent was blanketed with lush rainforests. India and Africa had previously broken free from this huge supercontinent called Gondwana and drifted away to the north. Australia would also break away about 50 million years ago, followed a little later by South America, and for the first time a current of water was able to flow without interruption around the Antarctic. This circumpolar current had a profound effect on the southern oceans and tended to isolate Antarctica thermally from the rest of the world. Gradually, Antarctica cooled, and by 20 million years ago, it had frozen over completely and was surrounded by the frigid Southern Ocean. Today, the near-freezing waters around Antarctica are rich in plant and animal life. Slowly, deep currents carry this nutrient-rich water northwards across the abyssal plain until it reaches the southern continental slopes of Australia and New Zealand. Rising up the slope, these cold currents bring with them creatures that reflect their Antarctic ancestry. But the shelf off northern Australia boasts a very different tropical fauna. Along the southern coast, some shelf groups are spilling over the edge, meeting and mingling with animals from deeper waters. Some deep water groups are attempting to move up the Australian and New Zealand slopes from the abyssal plain. And still other, more ancient groups are moving southwards around the slope, meeting as before along its southern edge. A complex and dynamic picture. Animals from 5 major geographic backgrounds in the midst of a struggle for supremacy right around the southern Australian coast. The prize? The capturing and securing of new territories, what's known in the jargon as adaptive radiation. Each year, as the East Australian current pushes southwards along the coast, huge swirling eddies break away and drift beside the main current. Here, the warm core of the eddy is coloured orange to distinguish it from the cold southern water surrounding it. These eddies may be up to 200 kilometres across, and biologically, they're a bit like islands, trapping tropical fish and other sea creatures normally found in the Coral Sea and swirling them far further south than they would ever normally be found. Warm core eddies are interesting and important for many reasons. Bluefin tuna often gather at the walls of the watery prison, snatching unwary tropical prisoners from the invisible wall at which warm and cold water meet. So by locating eddies, tuna fishermen stand a good chance of improving their catch. On the Franklin, we're fishing for more elusive creatures and using weird and wonderful equipment to do it.
That angle about 5 degrees. Right up and down. Oh.
As the trawler's hauled aboard, it's clear that it's been damaged. Fortunately, it's just a minor bend that's easily repaired. On a ship like this, the chief engineer has to double as village blacksmith. And this is what the fuss is all about, these bags of eyes. But the scientists are not savouring the chef's soup of the day. They're plucking out the tiny creatures and sorting them into their main groups. The first stage of classification. After several attempts, Tim Stranks has finally managed to land a squid. Not exactly a giant, but still closely related to those legendary monsters of the deep. Giant squid are etched into the mythology of the sea. For many an ancient mariner spending months, even years at sea, it didn't require much imagination, even less after a tot of rum, to visualise long tentacles curling over the gunwale, snaking out to encircle the poor unfortunate taking the dog watch. Those myths undoubtedly were fuelled by occasional sightings of real giant squid, some more than 20 metres in length. Tim's squid poses no threat to the Franklin or her crew. Its relatives, even though huge, are in fact elusive and rarely seen. In the Atlantic Ocean, the number of species of squid roughly doubles for each 10 degrees of latitude, increasing from just 3 species at 60 degrees north to about 40 species near the equator. Very few counts of squid have been made in Australian offshore waters, but so far there appear to be roughly equal numbers of squid species in both equatorial and southern waters. Clearly the Pacific pattern is different to that seen in the northern hemisphere, but just what that means for our squid fisheries has yet to be discovered. Tim's data will help to flesh out the story. Australia's fishing zone is roughly the same size as the continent itself, the second largest area of navigable water under the control of a single nation. It's all very well to lay claim to such a massive volume of water, quite another matter for a small country like Australia to manage it effectively. That's one reason Franklin was commissioned. Given that no one can manage what they don't understand, the wise use of marine resources depends on high-quality research. All too often in Australia's history, technologies tested in the Northern Hemisphere have proved disastrously inappropriate to the Australian scene. The persistent spread of our deserts attests to the failure of many farmers to appreciate the fragility of the soil. Far from being limitless, our oceans also need sensitive management, or they too will suffer a similar fate. Highest priority for this trip is the eastern face of the continental slope spanning Bass Strait, the turbulent stretch of water separating Tasmania from the Australian mainland. The sea may look deceptively calm, but these waters are treacherous. Without warning, strong winds can whip up frenzied seas that test the mettle of any who venture out from shore. Far below us flows what could be called the largest waterfall on Earth. The cool current flowing eastwards across Bass Strait plunges almost 1,000 metres down the scarred face of Flinders Canyon. Striking the even chillier waters rising from the abyssal plain, the waterfall is deflected northwards, finally slowing as it strikes the East Australian current. Here the plan is to fish for creatures living at the depth of the Titanic, 4,500 metres below us, deeper than any of these biologists have sampled before. Plans are one thing, but with isobars on the weather map coming together like straw in a clenched fist, our chances of catching anything other than a dose of seasickness seemed positively remote. As we rounded the eastern tip of Victoria, we ploughed into the teeth of a force 10 gale. I asked the skipper how he felt about being at sea under such conditions.
Well, there's sometimes when you're at sea you rather wish you weren't. You'd rather be at home sitting by the fire or something like that.
In this kind of sea, we had no choice but to point Franklin up into the wind and ride it out. I took the chance to catch up on my filming notes. Fortunately, by morning, the storm had spent its fury and we could get on with the job. To sample at such great depths, we have to play out 4,500 metres of cable, weighing about 2 tonnes. That means it takes more than an hour to reach the seafloor.
I'm all set.
The hydraulic A-frame over the stern is equipped with an oceanographic pulley that measures the rate of cable travel and the tension in the cable itself, around 8 tonnes. The winch operator needs a delicate touch. He has to keep the cable trailing just astern of the ship. Too much tension and it will snap. Too little and it could wind up wrapped around the main propeller. I say main prop because Franklin actually has three. There's a sideways thruster at the stern and another rotatable thruster under the bow. So the whole ship, all 1,200 tons, can be positioned on the sea with one hand, using a joystick like those on a Space Invaders game. This three-axis control system comes into its own when the heaviest and most dangerous of the sampling devices, the box core sampler, is being sent down. Unlike the sled, the box corer has to drop vertically, striking the seafloor hard enough to ram downwards into the mud. Then the guillotine slashes across, sealing the precious sample inside for the long trip back to the surface. No mean feat when the ship's being buffeted by 30-knot winds. Once it's safely secured on deck, the box corer can be prized apart to reveal its precious samples of seafloor ooze. It's difficult and dangerous work. The box corer has to be reset time after time, and at this stage of the trip, fatigue is becoming a major factor. The work has to continue round the clock, just in case the weather socks in again.
Clear to go, Yannick.
On this trip, cameraman Ivan Johnson and I have set up a seawater aquarium in which we hope to achieve the near impossible. Macro photography of deep-sea animals so fragile they'd never make it to shore. All this on a bench that never seems to stay in one place and which is never free of vibrations. Most of the creatures that are caught won't survive the trip to the surface, being dragged through the water for 3 hours. Any fish with an air bladder inside will sadly reach the surface fatally bloated by the rapid decompression. Most will be unable to cope with either the higher temperature or the blinding light. At 3,000 metres, it's perpetual night and just 2 degrees above freezing. Some of the tougher fish do survive, however, like these black, sticky hagfish. Not high on the list of nature's most attractive creations, except perhaps to biologists, the jawless hagfishes are among the most primitive fish on Earth. Related to parasitic lampreys, hagfish are scavengers of the seafloor.
My grandfather said these were pretty good for removing paint.
Pretty slippery.
Oh, they're very slippery and they exude an awful lot of mucus.
Even though the conditions are somewhat less than ideal for filming, we have a rare opportunity to glimpse what life might be like 3 kilometres below. And what a nightlife it is. work continuing round the clock, the creatures are coming in thick and fast. In fact, it'll take upwards of 2 years to sift and sort the thousands of specimens into any sort of order. This time we're recovering the beam trawl, a new design being tested on this trip. Like the sled, it's dragged along the seafloor to increase the survey area. A chain under the wooden beam startles fish out of the sand, and as they dart upwards, they're swept into the net. This little translucent sliver of fish is an eel elver, partway through its marathon swim from the Coral Sea to the streams of southern Australia. This looked like a chunk of coral, but it came from far too great a depth. Laurie Hammond explained that unlike the hermatypic corals of the Great Barrier Reef, this deep-sea variety doesn't need sunlight to survive. Many of these deep-sea creatures provide their own light in the form of bioluminescent spots and stripes. They really do glow in the dark. Most of the fish have huge, well-armed mouths. I call this a Pac-Man fish. It's little more than a stomach with a mouth attached. Some have large forward-pointing eyes that let them see their world in 3D. Of course, it's not just fish that are picked up.
What the hell's that? Well, it's a pycnogonid. It's a sea spider. Robin's got it upside down, but it's a very long-legged animal related to terrestrial spiders. They grow especially large in very cold water, which is the case here in this very deep water. These are quite common in shallower waters, but little animals, only about a centimetre or so long.
So this one's really huge?
Oh, it's huge, yes.
What do they feed on, do you know?
Hydroids, little feather stars.
They'll drill a hole into the animal and suck his juices out.
Sounds horrible.
Don't know what this one
The
is.
only pycnogonids I'd seen were from tidal rock pools, and they were quite tiny, less than a centimetre across. This one is beyond my wildest dreams. In the tank, buoyed up by the water, we can see how the sea spider positions itself. The long mouth tube angles forwards and downwards, with 2 pincer-tipped appendages at the ready. The lateral bars spread out below the body are used to carry eggs. Those white antennae on the head are goose barnacles. Even at 3,000 metres, freeloaders manage to eke out a living. Here the deck is strewn with sea spiders, for all the world like a pile of noodles at a Chinese restaurant. In order to preserve their animal treasures properly, the researchers must get them into fixative solutions as fast as possible. Normally there isn't time to see what they do when they're alive. This crab would more than likely wind up in a museum collection with its legs in a real tangle. Only when we watched it very much alive in our tank did we see how it prefers to sit. Hind legs high in the air like aerials, probably trying to catch objects that drift by. The crab's a junk food freak, and we noticed that any debris in the tank water inevitably caught around those hind legs, hitched to the sharp spikes and spines. Jeanne believes it may use its hind legs in camouflage. It's related to those more familiar decorator crabs that festoon themselves with what looks like an ornamental garden. Greatest surprise of all was to see these amphipods nipping around in what look like little plastic sea scooters. In fact, the scooter is another animal, one called a kelp, and it's been hijacked by the shrimp-like amphipod inside. Some amphipods will even snip out segments of jellyfish to use in the same way. Kelps belong to a remarkable group of animals called protochordates. They don't have a backbone, but they do have many features seen in higher animals, including vertebrates like us. In a sense, they're our nearest relatives among the simpler forms of life. The amphipod uses the kelp for protection and as an efficient means of getting around. Well, no one's perfect. "7 days at sea, 2 transects completed, including the crucial Flinders Canyon region. Many thousands of specimens have been collected, most species never described before. As the team reviews its progress, the feeling is optimistic. With just 1 transect yet to complete, the voyage is already a resounding success." How are you all handling the trip physically? I mean, Laurie, you've not been exactly well. How are you handling the trip?
Fantastic.
Actually, I reckon they're doing pretty well for only a few days out. I was expecting a few of them to be lying down dying, but it didn't happen.
Most of us have spent a couple of weeks at sea every year or so we do get used to it. There's always the first day when you come out of the heads and the ship starts to bounce around, and those corridors are not as straight as they were when it was in the harbour, that's for sure.
Now, obviously you're looking at very fine detail, small differences between species or genera.
How do you explain such fine detail to a non-biologist?
One example is the blue grenadier in southern waters, which feeds very heavily on a myctophid, a lanternfish, which occurs in very great numbers in particular areas of, off of eastern Tasmania as well as western Tasmania. And until we understand the distribution of the species that these fishes are feeding on, we don't really know what sort of limits there would be on the commercially important ones.
There's obviously the advantage that we can improve our knowledge of the area, get more fine detail of what's here. That's a bit theoretical, isn't it?
That's very true. All of this is, these are building blocks, and at the moment we're not quite sure what the information is good for, but sometime in the future will be picked up to look at various applied problems.
When we look at the continental shelves around Australia, we realise firstly that almost nothing is known about them, the continental slopes in particular. And it's also quite clear in Australia that if anything does happen to increase the output of Australia's fisheries, it is going to happen in these areas. It's not going to happen inshore. We know them pretty well and we manage them not too badly. And if you like, the type of work we're doing is preparatory work, so that when it becomes necessary to manage fisheries that get discovered on continental slopes, there's a baseline of information from which managers can work.
The average person in the street comes into the museum and sees specimens in their neat little glass cases. I bet they don't realise those specimens come from expeditions like this.
Now, those museum staff in the old days collect the samples that are now in the museums. They were out catching, knocking birds on heads, taking them home, stuffing them, catching fish. That's how they did it.
We're following a long tradition of exploration of the sea around Australia. It started before Cook's time, when Cook and Banks and his ilk, and later on some French expeditions were collecting in very much the same sorts of environments at the end of the 18th century and early parts of the 19th century.
How do you react to the proposition that a healthy community should tolerate both art and science, that art and science are actually much the same?
Well, it's more than just tolerance. I mean, it's an important thing we all should be living for, to know more about the environment we live in. Things like the VFL Grand Final and the horse racing doesn't have to justify itself in terms of producing anything concrete that can be sold to Japan the next day. I think that the sort of work we're doing gives us more satisfaction and more value than a lot of other things that we could be doing, and I think that that's something that we should be trying more to communicate to everyone. So it's really a very satisfying thing to go where someone has not gone before intellectually and try and explain a diversity or some other biological phenomenon.
Our spirits may be optimistic, but once again the weather map is furrowing its brow. There's yet another ominous-looking cold front closing fast. The decision is to run ahead of the front, trying to reach the relative protection of Tasmania's east coast. There, the continental shelf is quite narrow, so the final study area is fairly close to shore. But once again, it will get rough. Like a limpet clamping down onto a rock, we secure Franklin for the storm. Ever mindful of our needs, the chefs have dreamed up a little surprise. Piles of hot scones, pots of jam and lashings of rich cream. Just the kind of food to have as we steam into another gale.
There you go, Dave.
Oh, good thing about it, tastes even better coming up again.
The sampling is completed in just 11 days, but the analysis will continue for years. Like his colleagues, Jean will spend hundreds of hours observing the finest details on these microscopic crustaceans. Only by observing them closely enough to make line drawings do the key differences emerge. These mini beasts look fairly similar at first glance. If we take a closer look, we can see the kinds of features that allow Jean to recognise different species. That's how the evolutionary jigsaw is pieced together. A lot of time and a lot of patient hard work. And as for these ones... Those who live and work at sea know well that humans who venture far from shore are very definitely out of their natural element. Despite the power of Franklin's engine and the precision of the navigation gear, the storms remind us of our own frailty, of the immense forces that have shaped the planet, and of how little we truly understand of the dark undersea world beneath the waves. The sea was the cradle of life on Earth. Its creatures, from the tiniest crustaceans to the largest whales, continue to enrich the oceans as we should enrich our knowledge of them. Not just for selfish ends, but out of respect for the watery planet that is our home.